Hello. Today I'm going to solve the problem to second order ODE with constancy coefficients. Here's my question: y dot dot plus y dot plus y equal to 0. To solve this kind of second order ODE, we can assume the answer. Y equal to a exponential lambda x. And the situation a is just constant, right? So what about y prime equal to lambda a exponential lambda x, right? Y prime means that derivative for x, right? And what about y double prime is lambda square a exponential lambda x, right? And then we can substitute this value to the original equation. So substitute to the equation. So we can rewrite lambda square a exponential lambda x and plus lambda a exponential lambda x and plus a exponential lambda x equal to 0, right? And then we can rewrite a exponential lambda x lambda square plus lambda plus 1 equal to 0, right? So this guy is not equal to 0, so to satisfy this equation, this term should be a 0, right? So lambda square plus lambda plus 1 equal to 0, because a exponential lambda x is not equal to 0. Alright, so what is a lambda 1, 2? We can use quadratic formula, right? So 2 over minus 1 plus minus square root 1 minus 4, right? So what is a quadratic formula? Quadratic formula is ax squared plus bx plus c equal to 0. A is not equal to 0. X equal to a minus b plus minus b squared minus 4ac, right? This is quadratic formula. We can use this formula to solve the quadratic equation. So we can get lambda 1 and 2 minus 1 plus minus 3 over 2, right? This is same. We can rewrite this one plus minus I square root 3, right? So where I equal to square root minus 1, right? So what is there are two types of the lambda, so that's why we can find y1 in the first of all, a1 exponential lambda 1x, right? So a1 exponential 1 minus 1 over 2 and plus I square root of 3 over 2 x, right? And then we can also find the y2, a2 exponential lambda 2x equal to a2 exponential minus 1 over 2 minus I square root of 3 over 2x, right? So we can add all the answer, because by using principle of superposition. Principle of superposition. How can you use this kind of like principle? Because this equation is linear, right? The system is linear, that's why we can use the principle of the superposition. Understand? So if we add them together, 1 over 2x, right? A1 exponential I is equal to 3 over 2x plus A2 exponential minus I, here's plus and minus, equal to 3 over 2x, right? So we can rewrite these guys. How? Exponential 1 over 2x and A1 cosine x plus I sine is equal to 3 over 2x, right? And plus A2 the cosine is equal to 3 over 2x minus I sine is equal to 3 over 2x. How can I find this kind of answer? By Euler's equation, right? We can use Euler's equation. We can rewrite this one. So we can rewrite more like simply like this: A1 plus A2 cosine is equal to 3 over 2x, right? And then A1 minus A2 I sine is equal to 3 over 2x, right? So if we call this term is large A and this term large B, so we can rewrite the final answer more simply, right? A sine is equal to 3 over 2x, right? And plus B cosine is equal to 3 over 2x, right? So this guy is our final answer. Got it? Yeah, that's all today. Thank you.